Okay, so in this video and this series of in this playlist, I will discuss about uh, inverse trigonometric functions. All right, but to move into inverse trigonometric functions, we have to know about inverse functions first, and to know about inverse functions first, we have to know about functions first. So first we will understand something about functions. I will not completely pursue functions here, but I will give you a good understanding of functions. I will try to, so that you can understand what an inverse function is, and so that ultimately you can also appreciate what inverse trigonometric functions, how they work. Okay, so yeah, let's start. So what exactly is a function? What exactly is a function? A function is basically a relation from one set to the other set. Suppose we have two sets, A to B, and here we have A1, A2, A3, and we have A, B1, B2, B3, B4. So these are the two sets, and a function f such that it is from A to B. So A is the domain, B is the codomain. So suppose A is mapping onto B2, A2 is mapping onto B3, A3 is mapping onto B1, A3 is also mapping onto B4. So let this be the relation. Okay. Now F is a relation here. Suppose. Hmm. So we will also try to discuss the difference between relation and function as well. So since we have this line, A is connected to B1, B2, so A1, B2 is an ordered pair. Okay. Also A2, B3 is an ordered pair. Also A3, B1 is an ordered pair. And also A3, B4, that is also an ordered pair. So these four ordered pairs forms this relation F. Now look at one thing very closely, that this function F, this has this relation F, this is not a function. Why is this not a function? Because to become a function, everyone in the domain must be related to exactly one in the codomain. That is, A1 should be related to exactly 1. So A1 is already related to B2. So we have no problem with A1. We have no complaints with A1. A2 is also related to exactly 1, that is B3. We also do not have any complaints with A2. But look at A3. A3 is connected to B1 and also B4. So here is our problem, that this relation is not a function. The reason is this A3 is forming connections with two elements in the codomain. It should form a connection with exactly one. Everyone in the domain should form a connection with exactly one. So F is a relation. F is a relation, but F is not a function. But not a function. Okay, so F is not a function here. Okay, so let us try to understand this even better. So suppose we have a visitors set and we have a rooms set, rooms. Okay, so suppose we have visitors v1, v2, v3, v4 and so on. Suppose we have 4 visitors and we have rooms r1, r2, r3, r4, r5. We have 5 rooms, and suppose this is basically h, the function h. Suppose so, if h has to be a function, so what is h? H is basically a relation from visitors, set of visitors to set of rooms. Okay. Now if h has to be a function, each visitor should move into exactly one room. Okay. For h to be a function, each visitor should move to exactly one room. Okay, so suppose v1 is moving to r3, V2 is also moving to R3, V3 is moving to R2, V4 is moving to R1. Okay, so this is a function. This is a function. This is a function. But suppose we have another relation. So suppose H, what ordered pairs are we having? V1 R3, okay, V2 R3, we also have V3 R1, and we also have we have V3 R2, sorry, we have V4 R1. So we have 4 ordered pairs, and so this is of H. So therefore H is a function. Therefore H is a function. It is a relation and also a function. It is definitely a relation and it is also a function. Why is it a function? Because everyone in the domain is moving into exactly one room. Okay. So suppose we have another case. Suppose like this, that we have the visitors set, and we have the rooms set, and this time we have a function of G, a relation of G. Suppose we have the same 4 visitors and same 5 rooms. So if our visitors move like this, suppose, sorry. So here V1 is moving to R3. So what is G? G is a relation from visitors set of visitors to the set of rooms. Okay. And what is G? The relation of G will be V1 R3, V1 R3, V2 R2, and V3 R5. So this relation is also, is it a function? If I ask you a question, so is this relation a function? No, G is not a function. G is not a function. It is simply a relation. And why is that so? Because this function, look, this fourth element, the V4 is not moving into any room. So for becoming a function, everyone must have a pre-image, but exactly one image. So V3 is having an image of R5, V2 is having an image of R2, V1 is having an image of R3, but V4 has no image. So everyone must have an image, but exactly one image. Okay, so therefore G is not a function here. Okay, so this is the idea of a function. Now we have a few more concepts of, one is one function. Okay, look, I am not moving into a lot of details about functions. I am not going to make you do a lot of practice on functions, because this is not about functions. This is about inverse trigonometric functions. But before understanding trigonometric functions, inverse trigonometric functions, we need to have a good idea about functions first. So that is the reason why I am touching upon functions a bit. And so yeah, that's the purpose of this video. So suppose, what is a one function? A one function is basically, first it has to be a function. Now everyone should move to different rooms. Like no one can share a room. That's the idea. No one can share a room. None can share a room. None can share a room. Every room must have at most one occupant, at most one. So suppose you have V1, V2, V3, V4, and you have room 1, room 2, room 3, room 4, room 5. This is a set of rooms. Let me just put an R for rooms and V for visitors. Let this be the function. So if this has to be a one function, then V1 can move into any one of these. First of all, let us say R2. V1 is moving into R2. Nice. Now for V2 can move into any of the rooms except R2. Okay, V2 cannot move into R2. Why? Because one function, a room can have at most maximum one. Okay, look, one function is not telling that every room must be filled. No, every room need not be filled, but if it is filled, it should have at most one occupant. So v2 should not move into r2. So let v2 move into r1. So for v3 should not move into r1 and r2. So v3 has options from r3, r4, r5. Let it move into r4. So this is a 1 1 function. Okay, so this is a 1 1 function. 1 1 function simply means that everyone is moving into different rooms. Okay, no one is going to stay together. That is very simple. Okay, so this is the idea of a 1 1 function. This is 1 1 function. The next idea is, suppose we have a straight line, something like this probably. So this will be something like maybe 2x plus 3 or 2x plus 1 probably. Okay, let this be 1. Now so this is this a 1 1 function? Yes, this is a 1 1 function. If our function is from real to real and this is the rule of the function, then this is a 1 1 function. Why is that so? Because every x, suppose this x1 moves into this y1. Okay, so this is basically our rooms here, and this is our visitors, set of visitors. Okay, and this x2 is moving to this one. So you will see every visitor will have a different room. Suppose this is x3, x3 will move into y3. No two visitors, you will see that they are sharing a room. No two visitors, this is impossible for this. So this straight line is basically a 1 1 function. In fact, every straight line, every straight line except a horizontal line which is like a line which is parallel to x-axis. Okay, this is a constant function, like y is 3. Suppose this point is 3, right? This is not a 1 1 function, but except a constant function, every other straight line or a linear function, right? A linear function is always a 1 1 function. It's always a 1 1 function. Okay, so this is the idea of a 1 1 function. Suppose you have something like this, maybe a curve, something like this, something like this. So this is not a 1 1 function. Okay, why? Because look, because suppose you happen to draw if you can just draw a parallel line to the x-axis like this. This line is touching the curve into 2 points, right? And we can have x1 and x2 here. Now, so look, let this be y. So y dash. So x1 and x2 is moving into the same room y dash here. So this curve, whatever function it may be, let it be fx, whatever, this function is not a 1 1 function. Why is that so? Because we can have at least 2 points, 2 such points which are moving into the same room, right? Or suppose if we can have a parabola, something like this, maybe a very simple parabola, y equals to x squared, and this is x. So if we draw a parallel line and it can touch 2 points or multiple points, and this is x1, this is x2. Look, even this x1 and x2 is mapping onto the same y dash. X1 and x2 is mapping onto the same y dash. So it means that 2 points, two visitors are moving into the same room. So this is also not a 1 1 function. So these functions are not 1 1 functions. But not all curves are not 1 1. Okay, suppose something like this. I hope you have understood this, because this is x square. So if this is minus 2 and this is 2, you can see this will be 4. So minus 2 and plus 2, both of them will be moving into the same room of plus 4. Okay, so this is the reason. And not just minus 2 and plus 2, even minus 3 and plus 3, these will move to the same room of 9. 1 and minus 1, these two will move into the same room of plus 1, and so on. So these functions, right, these functions are not 1 1 functions. Even we can try some more examples, something like this, maybe, perhaps y equals to x cube. Y equals to x cube. Y equals to x cube looks something like this. Okay, And but this is a one function. This is a one function. How? Because if you can draw parallel lines to x-axis, and none of these lines, you will never be able to draw a parallel line to x-axis which happens to which happens to find two intersections or multiple intersections on the graph. Look, this line has only one intersection. This line also have only exactly one intersection. This line also have exactly one intersection. So every line which is parallel to the x-axis is having exactly one intersection. This means this is a one function again. This is a one function. This is for everyone. This x1 is mapping onto this y1, this x2 is mapping onto the y2, this x3 is mapping onto the y3, this x4 is mapping onto the y4. None of the x's you will never find. I have just taken 4 x's here. Obviously there can be many more x's, but none of the x's can ever, none of the two x's, you can never have two such x's which move into the same y's. Okay, it's not possible here. Why? Because you can draw these parallel lines and you can see that they will never intersect in more than one point. So this is the reason. Again, I'm telling you, this is not a, I guess, I'm just guessing that few people will find it difficult to understand this, but perhaps. But this is not a class where I will discuss functions in a great depth. So I hope you have done functions in class 11 and in class 12 as well. So yeah, so this is what one function looks like. Okay, but otherwise, if a function is not one, it is called something as many one. Okay, so one type of function is a one function. Okay, the other type of function is a many one function. A many one function. So what is a many one function now? In a many one function, what happens is at least two visitors will stay together. At least two visitors will stay together. That's the idea of many one. So if a function is not one, it will definitely be a many one function. Okay, so we have we suppose have 4 visitors, we have 5 rooms again, and so v2 and v3, let them be staying together in room number 4, and rest of them are staying in different rooms. So this is a many one function. In many one function, the idea is very simple, that we must have at least one room where we have multiple occupants. That's it. At least one room. We just need one room. We do not need every room to have a multiple occupant. No, at least one room with multiple occupants, with multiple visitors or occupants, multiple visitors. Okay, that's it. If you can have such a room where you have two or more, huh? Not one or more, two or more visitors, then that's it. That's a many one function. If you do not have such, then it will be a one function. A function will be either one or many one. It cannot be both at the same time. You cannot have a function which is also one also many one. You also cannot have a function which is not one and not many one, neither one nor many one. Okay, you will either have or one or you will have, it's kind of an exclusive or. It will be exclusive or, one or exclusive or many one. So that's the idea. Now another thing I would like to also bring into your attention is that for becoming a one function, so for a function to be a one function, the domain set must be at least the cardinality of the, wait a minute, no, the codomain must be at least the cardinality of the domain set. Okay, so if a function is something like this, a to b, okay, or suppose visitors to rooms in our example, so the if this function has to be a one function, like v1 v2 v3, and this is a set of rooms, right? So r1 r2 r3 r4. So the number of rooms, if this at all has to be a one function, the number of rooms has to be greater than or equal to the number of visitors, isn't it? Just think about it for a minute. The number of rooms must be greater than or equal to the number of visitors, because if it is not so, if if the number of rooms is less than the number of, yeah, visitors, suppose, huh? Then then at least two of the visitors will move into the year. So for one function, the codomain must be at least the cardinality. The codomain's cardinality must be at least the cardinality of the domain. That's very important. So we can say that this is true for this, and this is true for this. These two are very important part. Okay, I want you to please take your time and understand this. Okay, why this is important. For one this is very important, and for many one this is very important. For many one this is very important. Okay, just a minute. No, for many one this is not necessary. This is not a necessary condition. But for one this is necessary condition. Okay, this is necessary. Like if this is not true, it cannot be 1 1. If this is not true, this cannot be 1 1. Okay, but you can have something, but you can have this to be true and also many 1. Okay, so I can say that if it is 1 1, it will definitely be this, but it doesn't mean that if this is this, then it will be 1 1. Okay, I hope you guys know about the implication thing. Okay, so yeah, so this is 1 1 and many 1. Okay, next idea that I would like to share about is an onto function. What is an onto function? Also 1 1 function is also called an injective function. It's just another name to a 1 1 function. 1 1 function can also be, fancily called as an injective function. Why injective? Because I feel it's about something like an injection you put into our flesh. So injections are not shared. So so even rooms are not shared in 1 1. So injections are not shared by two people, two distinct people. So that's why I guess they have put this name injection. So anyway, that's not important, but you should remember this name about this term called injection. Injection means 1 1 as well. The third is onto. Onto has another name that is called surjective or subjectivity. So what is an onto function? An onto function is very simple. An onto function just tells us that every room must be occupied. That's it. I don't care how many people we have in the room. Just every room must be occupied. Must be occupied. Okay, so that's an onto function. Okay, these all are functions. Let me tell you, these all are functions. So a relation has to be a function first, and only then we can classify them into a 1 1 or many 1 or an onto. So onto is basically something where every room must be occupied. So something like this, perhaps like v1, v2, v3, and r1, r2, r3, r4, r5. Look at one thing here. This cannot be an onto function. Why? What is the reason? Because we have at least 3 members. At most we have 3 members. Like if this moves to this moves to this, and this moves to this, we are going to be left with 2 rooms unoccupied or empty. So we need some more visitors, right? We need at least 2 more visitors, so that this moves to this moves to this, I guess. Yeah. So for an onto function, you can definitely see that the number of visitors should be greater than or equal to the number of rooms. Otherwise, it is not going to be an onto function. So for an onto function, it is very important that the number of visitors is at least the number of rooms. That is, the domain cardinality must at least be the codomain cardinality. Very important. And more importantly, look, here the codomain and the range are the same. Whatever is the codomain, that is exactly the same. For onto function, you can simply say that codomain and range are equal. I guess you understand. You know what codomain and range is. Codomain is the entire right hand set, and range is exactly those rooms which have been occupied. Not all rooms are always occupied, right? But in onto, all rooms will be occupied. That's why codomain and range are equal. So yeah, so that's an onto function, which is also called a surjective function. Huh? So now, so now notice one thing. In one and many one, we were talking about the domain. We were more interested in the domain, right? Like we were saying that the visitors should move into different rooms in this case, and in this case we talked about that visitors should, at least two visitors should move into the same room. So in both these cases we were more concerned about not the rooms, we were more concerned about the visitors, right? But in this case we are concerned about the rooms. Okay, look, in these two cases, in one we were concerned about both. Here we are concerned about the visitor, right? That no two visitors should stay in the same room, or every visitor should stay in different rooms. In this case, number two, many one function is at least we should have at least two visitors or three visitors or four visitors who are moving into the same room. That is when we have a many one function. So in these first two cases, we were more inclined to think about the visitors, while in the third case, in onto function, we are not talking about the visitors that much. We are more interested in the rooms this time. When we are telling that who is an onto function, an onto function is simply whenever the rooms, all of the rooms are occupied, or none of the rooms are left unoccupied. Okay, so this is the case. Now so a function can be one, right? Or it can be a many one, or a function can be onto, or it may be not onto, right? So what is a not onto function? A not onto function means a function whose all of the rooms are not occupied. Suppose something like this, perhaps maybe v1, v2, v3, and you have room r1, r2, and r3, and suppose this is happening, something like this. This is not an onto function. This f is not onto function. Okay, but it is a many one function. This is a many one and not onto function. So look, in here we are talking about one and many one. So here we are talking about the visitors or the domain. Okay, in this columns, and in these rows we are talking about the codomain. Okay, or the rooms or the codomains, right? So a function which is one and also onto, this function is a special function. This is called a bijective function. This function is called a bijective function. Okay, another thing I should have written here, that is the number of visitors. If at all it has to be an onto function, then the number of visitors should be at least the number of rooms. That is the cardinality of a domain should be at least the cardinality of the codomain. Okay, so this function is a very special function. Now a function which is also one and also onto, injective and surjective, that function is called a bijective function. Okay, that's a very this is a very important function, and we want to remember this function. We will talk a lot about this function, and inverse functions come from this function. Okay, we will see how this happens, but yeah. And this function is basically a many one function and also an onto function. Okay, suppose no, this is not a many one onto, this is simply a many one and not onto function. So this is one, this is a one, and not onto function, and you can see that I'm just using the notation of onto complement. It means not onto. Okay, and this is basically a many one and not onto function, many one and not onto function. So this function is this function goes into this category. So we have these four category of functions. Okay, a bijective function, a many one onto function, a one not onto function, a many one not onto function. Out of these four categories, this category is of major importance in class 12 and in this chapter of inverse trigonometry. So yeah, right. So this is what I wanted to talk about bijective function. In the next, I'll also talk about inverse functions, and perhaps we will start with our inverse trigonometry as well. Thank you.